the area for a given, for a circle, when we reach here, we have -4 here, which is the integral of the root of r squared minus r squared cosine of theta multiplied by r sine theta d theta. So we want to look for the boundaries. The boundaries is what we need to put here. So we need something here and this side. So that is what we want to find now. So to do that, let me take this one up a bit. Can take this up a bit like this. So we want to look for the boundaries. We want to look for the boundaries. So write in your book, for cosine of theta, cos theta, write cos theta now. This is O. Are you writing that? We know that cos theta is given as adjacent all over hypotenuse. So it is x all over r. According to what we have initially, here, if you bring this here, we know that the cosine of this angle, which is an acute angle, is going to be x divided by r, since r is the hypotenuse. So, Rajan, can you listen and follow the class? So this one, when x is 0, our x in this case is going to be 0, and the cos 0 is going to be the cosine, right? Cosine of theta. Theta is simply 0 all over r. 0 over r, which is equals to 0. Because when you find cos 0, whatever you get here is also going to be 0. So also we find the cosine of r. Cosine of what angle is 0? So the cosine of what angle is 0 is simply going to be theta, which is equals to pi all over 2. Pi over 2. So now take this and put in one of the boundaries. Here is pi over 2. Can you do this? This side is pi over 2. If you have done that, we continue now to find the other side. When x is equals to r, our cosine of theta is going to be r divided by r, which is equals to 1. And you look for what is cosine of 1. So theta in this case is simply 0. So you come back to this side. You come back to this side, this boundary here, and put 0. This is 0. Can you do that?
Yes.
You have done it, eh? Okay, so now that you have done that, we continue. So what you are having now, in the recess, what you are having now is simply area. Area, let me write from here. So this is area, is given as -4, the integral from pi over 2 to 0 of this square root. The square root of r squared minus r squared cos squared. This is cos squared theta. Extend this. This is the root. Now multiply the whole of this with r sine of theta d theta. Have you written that?
Yes.
You can see. So now what this tells you is that to remove a negative here, to remove this, you see this negative sign?
Yes.
For us to remove this negative sign, we take the inverse of the function. So you just switch, or you bring this one to this side and you bring 0 here. So this one will become area is equals to, now it's going to be positive 4. The integral, now this one becomes 0 and this one becomes pi over 2. That is how we remove 0 of, now it is r squared minus r squared cos squared theta multiplied by r sine theta d theta. Have you written that? Yeah, don't worry. You know, this is why I told you it is a Form 4 work, but most of you insisted from class that I show you. So I will show you this. Hopefully after Mandamano we will be able to discuss more physically. Is that okay?
Yes.
Yeah, so here I just wanted to show you how we get that formula so that we are able to use the formula and calculate. Now from your 4-figure table or your trigonometric table, there is this thing that is written in that 4-figure table. That's sine squared theta. Write this down. Sine squared theta plus cos squared theta is equals to 1. The whole of this is equals to 1. Have you written that?
Yes.
And we also know from that table that sine squared theta, this is plus here, is going to be 1 minus cos squared theta. Write it. You have it, eh?
Yes.
So we are going to take the whole of this one, because this one can be written, you see this one that we have here, it can be written as 4, write 4, the integral, this is the integral, let me make it a bit clear, let me clean up this. So this is the integral from here, and we know this is from 0 to pi over 2 of r squared. Instead of writing this cos squared here, you will simply have 1 minus cos squared theta, this one. But remember that the whole of this one is under the square root up to here. Multiply this by r sine, r is going to be multiplied by r, now it is r sine theta d theta, sine theta d theta. Have you done that?
Yes.
You see, we are still trying to drive that formula. That's why I told you guys that it is a very tedious work. But I will show you. I will not miss every step, any step on it. Are you learning how to drive it, eh?
Yes.
Just in case I give you this in exam. If you see this one in exam, how will you feel? So, area now, right? Area now is going to be 4, the integral of 0 to pi all over 2. But now, instead of us writing 1 minus cos square theta, we know that 1 minus cos square theta is equals to sine square theta. So you will write r sine square theta, r sine theta, and sine square theta is like saying sine theta minus another sine theta. So r sine theta again d theta. Write that down. when you do this now, you will observe that we are done with that the square root, because you can simply take this one that you have here, 1 minus cos squared theta, divide by 2, in order for us to remove that square root, so that we have r sine theta minus r sine theta d theta. So area now is equals to, you can bring whatever you have there. Front, you have 4, the integral of pi over 2, this is 0, and then r squared, sine squared, sine times sine, just bring them together, sine squared theta d theta. You have that down. Now there is another identity that I want to show you. As another identity, we know that cos 2 theta, cosine of 2 theta. Have you written this down? This is equals to cos squared theta minus sine squared theta. So cos theta in this case, cos 2 theta is going to be 1. Instead of cos squared theta, you write 1 minus sine squared theta. Sine squared theta minus another sine squared theta. Write it down. So our cos theta, or cos 2 theta, is going to be 1 minus 2 the sine, or sine squared theta. This will tell you that 2 sine squared theta is equals to 1 minus the cos of 2 theta. The cos of 2 theta. This is the cos of 2 theta. You have that down. Math is sweet, eh? So from here, you can now write down that your sine squared theta is equals to 1 minus cosine of 2 theta. Then divide the whole of this by 2. Then you take whatever you have here and replace in our original equation. Our original equation is that the area is equals to 4r squared, the integral. This is the integral of pi over 2 to 0. This is 0 here, of 1 minus this one that we have here, minus cos 2 theta, all this divided by 2 d theta. So we can take this 2 to this side. If we take that 2 to that side, what you will have now is going to be area is equals to r squared divided by 2. These 2 here. The integral from 0 to pi over. Are you still following? Of 1 minus the cos of 2 theta. This is 2 theta d theta. d theta. So now we can integrate this.